Now let us turn to a speaker from Mitsubishi Material Corporation. Mr. ARIKI Kazuharu is assistant to the General Manager of Renewable Energy Business Division. He's to talk about the future of the geothermal power.
ただいま、
Thank you very much for your kind introduction. I am ARIKI of Mitsubishi Materials. This 50th anniversary Sunshine Project Symposium. Thank you very much for this opportunity to give a talk here today. Today's title is Future Renewable Energy and Geothermal Power. So today, on the right-hand side, there is agenda or table of contents for my presentation today. So conventional geothermal and next generation geothermal, what are the different?
のある発電を在来型地熱
We have a conventional thermal, which we already have infrastructure in place. For example, supercritical and EGS. These will be the next generation. So today, about such these new geothermal, as an operator, we'd like to talk about our current situation as well as future outlook.
地熱発電
First and foremost, I'd like to discuss the necessity and significance of a geothermal power generation. As you can see in the footnotes of this slide, the red one is the strength of Japan's geothermal, and then the blue one is strength of geothermal in general, and then the black is strength for renewables in general. So for us, we have the third largest potential in terms of geothermal heat generation, and we are not affected by weather events and so on. It can be base load, so we also enjoy the largest size of operation as well as share in the world. Next, I would like to talk about the characteristics of geothermal resources as well as business. So the characteristics would be that the ground resources are invisible, so they are not all over the place. They are only in certain locations. And also water, heat, and also insulation are the three requirements that have to be read and met. But if handled appropriately, it can be a sustainable one. As for the characteristics of geothermal, there are 2 points. That is the development of resources underground as well as power plants, construction and operation. Because we deal with underground resources, exploration and assessment can be very costly and time consuming. And at the same time, the promising areas tend to have hot springs and also abundant nature. So having harmony with the local community as well as nature is important. So about the environment of hot springs as well as nature preservation, we have to get understanding from local people.
このスライドは
This slide
村岡先生がお示した日本の
Professor Muraoka showed earlier in the first half, and this is actually the same graph. So in 2012, a filter system was introduced. So ever since, many businesses went into this space and many geothermal power plants were established. At the same time, some of the power plants were revisited in terms of the output, or they were even abolished. So the capacity is actually declining. On the right-hand side, the top graph is after 2012, how many power plants have started operation, and then down below is the capacity. So the blue graph is less than 1,000 kilowatt, and then the red one is more than 1,000 kilowatt power plants, and then dotted line graphs are the track records. As you can see, since 2012, approximately 80,000 geothermal power plants were established and operation began. But all of them, or most of them, are small-scale ones. And then since 2012, in total, 80,000 kilowatt is the newly built capacity. So the capacity needs to be expanded, and to this end, large-scale projects need to be accelerated. This slide talks about Japan's main power plant locations. In Hokkaido and Tohoku region and the Kyushu region, there are some large ones. As you can see in the slide, Japan's geothermal potential is approximately 23.5 million kilowatts, but under development and construction included, only 3% of that is used at this point in time. This slide, left-hand side, is
地熱調査、開発地域
development areas as well as investigation supported by JOGMEC and businesses. And then on the right-hand side, these are JOGMEC unique potential research result or areas. So we as a geothermal operator, JOGMEC is working with the Energy Agency and MOE, and I hope that they'll continue to do so, and especially within the national parks, they should study the areas that have been unexplored up to this point so that some business activities can be implemented. This slide talks about the challenges as well as initiatives by the geothermal operators. So on the ground, as I said earlier, geothermal characteristics exist, and in general there are 4 major risks, and we are currently struggling. The first one is a risk of developing underground research development, and then the second one is a difficulty in reaching consensus, including onsen hot spring operators, and then the third one is a social regulations such as the Act on Hot Springs, Natural Park Act, as well as the Forestry Act, and then the fourth one is the same for other renewables, the difficulty of system integration. So it is necessary to secure commercial viability and reduce the lead time, and to this end, as you can see down below, we are taking some countermeasures. So I would like to talk about initiatives of geothermal developers. From now on, so those efforts include, first and foremost, against the risks, we have to come up with measures about underground development. As an operator, we have to boost our management capability, and we have to enhance our technology. That is most important. So this is a list of efforts we make, but other operators are also making efforts to improve the technology capability. Since the resources underground, so to efficiently develop it, 3 elements of geothermal, water, heat, and insulation, have to be fully taken care of. As for heat, if you reach near the volcano, the heat is high, and at the same time, high level of exploration technology is necessary, but it's not available yet. So JOGMEC and NEDO are now developing new exploration technology. For example, on the right-hand side, thus VPS methodology can be, for example, applied in the future. And this is actually a proprietary technology, so we are trying to develop it and to drive down the costs. Of course, along with underground and overground facility, it is necessary for us to improve our drilling technology. So we are working with relevant operators and companies, and we are also trying to introduce overseas technology so that we can use this for our own development. So about such exploration and drilling technology, we try to accumulate track records, and we are sharing information amongst operators so that we can beef up the national capability as a whole. This slide talks about some initial efforts by local communities. We are trying to get understanding from local people. So before we start the on-the-ground investigation, we are making some efforts with the local community. After we get understanding, we start the actual operation. So we provide explanations or awareness raising seminars, and we will share information about our industry, plans of our projects, as well as results, so that we can win the understanding of the local community. As for hot springs monitoring, onsen hot spring has 3 elements: temperature, amount, and substances. And we also consider the relationship between our business and their operation. We do investigation and research on a regular basis and understand different events. As time passes, we provide explanation to onsen operators so that we can maintain positive relations. This slide talks about environment preservation measures. Happy geothermal plant, which was launched in March this year. Environment assessment law covers this size of a plant, so environment consultants have to be partnered with. We have to ask them to apply monitoring and so on. We need to get experts' input and share information with stakeholders, and we have to do the investigation and development. And especially plants, animals, and scenery can be affected, but the impact should be minimized, so we are optimizing our construction operation. Also, environment assessment doesn't cover certain sizes of power plants, but on a spontaneous basis, we receive advice from experts and then pay attention to sceneries. Some operators do that. And the next I'd like to talk about the policy of geothermal power generation of Japan. There was a talk by Resource Agency official. This is the 6th Energy Basic Plan adopted in October 2021, and this is a part that's concerning the geothermal. This is a mid to long-term energy guideline for energy policy of Japan, and this plan is reviewed once in 3 years. And as was mentioned earlier, in May this year, the 7th Energy Basic Plan started being considered. And as you can see in this slide, the necessity of the geothermal as well as its significance were explained, and they are talking about the strengths of this power source and then the environment ministry's targets and some other measures that are explained here. Next, I'd like to talk about supercritical geothermal power generation, which is the next generation geothermal. This one exists deeper than conventional ones with a supercritical condition, and we leverage water. And going forward in the future, this may be put into practice. This supercritical geothermal power generation has a strength of being able to establish a large-scale power plant across the globe. There is the drilling project in Iceland, and then in 2012, there was successful eruption experiment, and 30,000 kilowatt steam was released. In Japan, in 2011, Tohoku University and AIST demonstrated leadership in forming a group, and they did a demonstration study for supercritical power generation, and they made an international proposal. And in 2013, in Sendai City, an international workshop was hosted. And then from FY 2017, NEDO, in regards to heat extraction, has started a feasibility study, and then supercritical geothermal power generation promising area investigation started to select such candidate locations, and the necessary developments and R&D have been continuing ever since. On the left-hand side, what's shown is that in regards to this form of geothermal power generation, in June 2021, METI compiled 2050 carbon neutral green growth strategy, and promotion of supercritical geothermal is included. So Perob, Skype, and offshore wind power generation are also emphasized in the plan. Now, let me talk about EGS, Enhanced Engineered Geothermal System. E can be both enhanced and AO engineered. As you can see in this slide, artificially, the space can be created, and also artificially power generation or heat generation is possible. EGS during 1970s, Los Alamos Research Institute made a proposal. This idea for the first time, at the time it had a different name. And then during 1980s, NEDO and the Central Power Association started working on a relevant project. And then because of the power generation cost and also the collection of injected water was problematic, so it ended at one point But recently, because of the progress of technology such as drilling and promotion of renewables, led to resumption of EGS-related efforts by JOGMEC and others. This EGS as well as a supercritical geothermal, once if they are put into practice, then we can generate so much power from these solutions. So next generation technology development can be utilized for conventional geothermal power generation, then development can speed up. Then the amount of power generated by geothermal could expand, and the scope of the industry could extend even more.
整理して記載して
Finally, I'd like to sum up my presentation. This is a list. I'd appreciate your support for geothermal power generation. Thank you very much for your attention.
はい。有木様、ありがとう。
Thank you very much, Mr. Ariki. Well, thank you very much for sharing all the initiatives, challenges, as well as hopes for future technologies. The presentation was very comprehensive. So I'd like to ask a question. In one of your slides, geothermal businesses activities were introduced and human resources development was mentioned. And you are a business operator. And in this industry, what is the current situation of human resources or talents? What is the current state of play?
先生の方から
Professor Muraoka, in the first half, talked about the stagnant state of geothermal for 15 years at one point, but then some people left the space. And then since 2014, geothermal was promoted, and my company included for new graduates and mid-hires and from other industries, new people came in. So we have been developing them on the ground OJT. But drilling is one space where human resources are more scarce. So we see downsizing talent pool. It's difficult for us to secure people. So overseas drilling personnel, for example, people from Vietnam and so on are supporting us. And Japan's geothermal drilling is supported by such overseas talents. Well, thank you very much. We'd like to keep listening to your presentation and continue discussions, but it is time to conclude. Please give him a big round of applause. Thank you very much, Mr. Ariki.
NEDO